So actually, I think one of the things that which comes out of this discussion is that this trying to reproduce work as a starting point, as Arun said and as Andrew also pointed out, first of all makes you very familiar with the area, and it also helps you build your sort of the kinds of experiments that you are trying to try out. So, and in that process, one of the ideas that you have to become comfortable with is that eventually when you are further down the road, your results may add up to something significant, but on a day-to-day basis, most of the time your experiments or your results are going to be small steps. Each individual step will add to something. So just making a small experimental setup may take you like 2-3 weeks to get an experimental setup that is working correctly, where you have been able to, when we said, reproduce some original, some already published data, that experimental setup is able to actually consistently reproduce some data. So that takes some time. So if you have managed to, if you used about 2-3 weeks to set up that experimental process, that is not a waste of time, and you should feel happy. That you have actually progressed from having nothing. You had a clean slate, you had a clean board ahead of you, and then now you have a setup that consistently gives you data that is believable, defendable and believable. Now you can try some new sample. So this idea that there are small steps that you have to work on is something that you have to get used to. And for those small steps to occur, you really need to be a regular researcher. So you have to put in those hours in the lab. It is not something that you can, suddenly one fine day everything will be in the lab and your first experimental work. It doesn't work that way. You have to keep working on it slowly and steadily, and therefore those regular hours in the lab really makes a difference. I would also like to add that sometimes there is this misconception that only if you are working late night hours that you are actually doing great work. It is not like that. Even if you work very regularly from 8 in the morning to 5 in the evening and then take your evening off and be free and comfortable, you could still be doing great work. You could still be doing research work. You may be thinking about your research later in the evening without necessarily running the experiment at that point in time, but still that would be a lot of good work. So just keeping up those regular hours helps you add those small steps, which then add up to something that is significant.
In all of this, actually, the notebook that Andrew mentioned earlier is the central aspect. So, noting down, let's say you suddenly, while you are looking at some equations and you notice some dependence, it depends on the cube root, note it down, observation. So, it's a simple, small fact, but it's an observation that should come into your notebook. Or let's say after 1 week of things, you plotted something, plotted, graph it, put it in your notebook. Okay, that's a simple result that you got.
These days, it's a lot easier to do this electronically also.
Yeah, electronically. So all that should go into your notebook. So these are all these simple observations, results, which then eventually will be helpful to build later on.
Yeah. So one further point I want to make about all this, when you get a small result, you have to be, first of all, excited by it. You have to believe in it, and you have to be confident about it, and you have to proudly talk about it to others, your peers, your students, your advisor, everybody, and you have to show that visibly. I mean, it might look like, why should I be so proud about something so small? I'm doing something so small. Several other people are doing great. Yes, they might be doing something great in your opinion, but you have to be also proud of the small thing you're doing. The reason is there are lots of reasons for it, because when you're proud of that, you keep thinking about it a lot. You go going back and back about thinking about every single way in which it can be extended, and all that builds up on this small result of yours, and you get a bigger result. So, I mean, Pratap was mentioning experiments a lot, and this doesn't necessarily apply only for experimental work. Even for theoretical work, all these things are true. The final big result that you derive, a theorem that you derive, doesn't come just like that. You might show it for one special case one day, and then one more special case. But if you don't believe in it, you're not excited by it, you don't have confidence in it, you're not going to keep exhausting all the cases and build the general idea that gives you the big result. So it's very important.
I just wanted to add, in continuation of what Andrew just said, somehow there is a misconception that experiments have to be performed carefully and simulations don't have to be. Okay, the same rules, when we teach courses on design of experiments, we make it very clear that all the rules that you learn, all the theory that you learn in design of experiments equally applies to simulations. The only difference is in simulations, you can play around a lot more, but research is not just about playing around, it's playing around with a purpose in mind. So even experiments are done with a purpose, simulations are done with a purpose. So you have to choose your simulation settings, you have to know how your simulator works, what kind of solvers are being used, and what is the engine that's running underneath, and so on, to make sure that you have chosen the right settings and tool that you're using is being used for the purpose. Because Simulator is a very deadly weapon, and you can actually end up producing so much data, and only a small fraction of it is going to be useful to you, and you may be lost in that heap of data. So please remember that the rules that apply, the theory that applies to experiments, or equally applies to simulations as well, and like Andrew said, even to theoretical work.
And then there's a small point about the discipline also. When we see one small result that is promising and we are proud of it, to grow into a big topic worth making a publication or a presentation and maybe becoming a whole thesis by itself, that process requires a lot of discipline. So putting in those hours every day and being very meticulous about the day-to-day work, and then subjecting every extension to the logical process is very important. And if you go around the labs where research is being done, whether it is universities or national labs or research divisions of companies, you actually don't see too many people in dirty clothes, long hair, unkempt and working in wee hours. Actually, you see normal people well dressed and coming to their work for a significant number of hours every day, maybe more than an average employer, because you see that people do put in more number of hours of work in research than outside. That is mainly because of the passion, but you need to put on a regular basis and in a disciplined manner so that you can grow your small idea to a big one.
But funny, there are some badly dressed researchers also.
No, having said that, I think I just want to reiterate what Pratap just said, that see, in research, your thinking does not end with the time you close your lab or your computer or your notebook and so on.
Yeah.
The thinking process is a 24-hour process. It even appears in your dreams. I don't know if you know, Kekuli discovered the benzene structure in his dream, right? Which means he was really thinking into it, maybe thinking about it while he was eating, in his shower, where he was walking, running, everywhere. So I think research, the thinking process, the thought process that goes into it is a never-ending one. You can't close that lab of the mind that J.C. Bose mentioned. That lab cannot be closed. All the physical labs you may close, but not the mental lab that you have. So make sure that you are thinking about the problem, and you will hit the treasure very soon.
So another quote in this context of whatever we have been discussing so far is attributed to Thomas Huxley, and it simply says, science is simply common sense at its best, that is, rigidly accurate in observation and merciless to fallacy in logic. So I think that sums up some of the ideas that we have been trying to convey so far. We will now look at how do you, as you start collecting all those small results and building up your repository of results, how do you know that your results are right? How do you know they are significant? And what is the process involved in this? So maybe Andrew can start with that. First.
Yeah, I want to say something.
Yeah.
So basically, I want to say that the research enterprise that we have been having for several hundreds of years is not a democratic process. That is, if everybody agrees to it, it's it. No, it's not like that. One expert can prove everybody before him was wrong, and then his or her idea can then prevail forever after that. So it's not a democratic process. It's also not a process where somebody highly recognized is able to tell and then everybody agrees. So it's a process where actually the peers are willing to review each other and then hold something as true so long that it has not been disproved. So that peer part is very important, and if you notice the way we go about disseminating the research results, it's basically by peer review and then peers criticizing and validating each other's work and going about. So identifying what is your peer community is very important, and I think professional societies play a big role in that aspect, and you have something to say on professional societies.
Yeah, I think that's important. Quite a few. I mean, we all work like Fanny was mentioning. It's a global area of work today. I mean, you can't say my work applies only for India or in some in a local way. It doesn't work. Research is global today. Your competitors are all over the globe. Definitely in China, Japan, USA, Europe, everywhere, and all of those places are connected together by the peer community, and the peer community is international, and there's also a significant national peer community, and you have to identify that peer community. For instance, in electrical engineering, many of these areas, IEEE is a big peer group, and the technical societies of the IEEE cover almost all the areas of engineering, and I'm sure every area has similar things. There are local chapters, etc. The important thing to do is to identify the journals that are run by these societies of reputed peer communities, and then identify conferences that are run by them. Okay, there's lots of things there. They'll give something called technical co-sponsorship, etc., etc. Those are different from the conferences that the society itself runs. Okay, so you have to identify those which are critical, and then try to see how high you can go. And there are different levels there. I mean, there are different gradations for conferences, different gradations for journals, even when it's run by the same society. And it's okay to identify the best you can do and then be wherever you are. But identify solid, reputed research peer communities, both nationally and internationally, and try to publish your results there. And that is the number one way of figuring out how relevant your work is, how good your work is.
So I just wanted to add, going back to the question of how do you know your results are right and significant, right? Now, as I think I made this remark earlier as well, that you need to have an intuition. Sometimes you don't, sometimes you do, but you do develop the intuition with experience. And somewhere you know that this result makes sense or does not make sense, which means that when you get a result, it's important to validate it qualitatively and quantitatively. That's the first important step. If you want to say the result is right, the conviction should begin from you. You should not depend on someone to say it is right, right? And then discussing with your advisor, that's the second step, because there is a discussion and maybe you are right and you can convince, or maybe you're wrong. Then sharing it with your own research group. So run your results through, make a small group presentation. Even if your advisor does not insist on it, you say that I would like to discuss these results in the open with my group mates, because and hope that you will get a critical feedback. And very often you will get a critical feedback. Simple discussion, like they say, when you are upset, when you are sad, simply pouring out your grief, listening ear will really help you. Likewise, when you are excited about your results also, sharing it with your group members really helps you, because a lot of perspectives come in. I think the key word in research is perspective. And sometimes insignificant results can become very significant just with a change of perspective. And that's a very important part. And then comes sharing it, communicating it to the scientific community through conferences, through papers, and so on. And that's where the peer community plays a very important role. But the starting process is with you. You are the owner of the problem, you are the owner of the result. You take complete ownership of the credibility of the result, right? And for that to happen, you should have done enough validation, either theoretically, experimentally, through simulations, whatever. You should have a second way of showing that your result makes sense.
So there's one point that we want to make about learning. Do we go into every specific detail of every tool and pick up all the things before we embark on research? So in research, I think there's a combination of multiple techniques of learning. So we normally talk about what is called just-in-time learning, which is applicable to, for example, when you're making a dish out of a recipe. You need to only know the detail which is necessary to make the dish. You're not going to the theory of what can mix with what, for example.
And you don't want to know the science of material.
You don't want to go into the science of
right.
And then there's also another learning paradigm called strategic learning, where you basically have a goal, and up to achieving that goal only you are interested. You are not interested in anything else. Okay. And then there is another paradigm called in-depth learning, where you are really interested to go to the bottom of the knowledge and then get that knowledge to your long-term memory. I think research encompasses all these three in a way. For example, let us say you want to quickly make a plot in a way that conveys the idea. You want to pick up a MATLAB script for that. So you just learn to that extent. You don't need to go in to see how MATLAB actually is doing all these things. And then strategic learning, you need to basically solve a problem. You understand only to the extent that is necessary to solve. But then when it comes to your own core area of research, I think it is very important to achieve in-depth learning. So it's very important to be a little agile in the way you learn about in research. The way you have been doing in the high school or when you are preparing for these entrance exams doesn't apply to research. So your attitude of learning has to change the moment you want to start on
And
research.
all three have different time scales, obviously.
Yeah, all of these are at
different time scales, and PhD typically involves all these three, and probably converges to in-depth. Starts with just in time and ends up with in-depth.
Right. So in research, one of the aspects we have not touched upon so far is teamwork. You actually consciously or unconsciously participate in teamwork. Rarely we have, I mean, it's not that it's impossible, but in general we don't have people who are completely isolated and then doing research on their own. There are some, but in most cases we are working with a group. You are typically a student in a group or a postdoc in a group. And so there are people with a wide range of different experience who are working along with you. Some you are learning from, some you are teaching, and sometimes the roles are reversed. And so that's a process that you have to get comfortable with and you have to understand. So it is always going to be teamwork, and you have to be willing and happy participant in it. You will invariably find groups, and you will invariably find the occasional researcher who does not like to participate in teamwork. I think in the long run that's not a great idea. Maybe in the short run you do see one or two of them being successful. They try to hide the resources, they don't share the resources and so on. But in the long run that's not a good idea. World does get along. We spoke about peer community and so on. It's the same peer community that they'll see that you will see, and it's just a matter of time before people accept that this is not a person that's easy to work with. So teamwork is very important. You should know how to work with the people around you, and you should know how to share credit. So when you write publications, you should know whose work was the core of that particular publication, and therefore that person should get priority. And so that's something that you should become comfortable with. And just to share a quote here, it is from Isaac Newton, and it's something I'm sure many of you have heard of. It says, if I have seen further than other men, it is because I have stood on the shoulder of giants. And I think that very beautifully captures this idea of teamwork. In fact, he's talking of teamwork in a grander scale, where he's talking of not just his group, but other people who worked before him in various parts of the world who have contributed to that area, and he has understood those contributions and built on those contributions. So that's teamwork in a grander scale, but there is teamwork even at a local scale.
Yeah, even much local scale. For example, you may be using the same computer, you may be using the same balance to weigh things. And so there is teamwork involved in everything, because there's coordination, working with each other. So all of these are very important aspects of research.
Interacting with the team really gives you good breadth of the research, which is also important in a research, not just your own depth getting lost and so on, just not going single one-sided.
So having an active group, for instance, going into an active group which is publishing in conferences regularly, publishing in journals regularly,
it's positively contagious.
It's huge, and it just gives you the setting and the atmosphere, and completely changes your attitude to everything, and you'll be surprised how that can make a big difference. When you're starting out in research. Going into an active group is very crucial, and that it's you might say some of them you might work with and they might be part of a team. Some of them you may not even work with, but just that they're there and they're talking about things and they're exciting you and you're motivated by them. It works in a great fashion.
So yeah, we're sort of getting closer to the conclusion of this discussion. Just a couple more points before we look at some general aspects about human characteristics, research characteristics, and then we will close this discussion. So one of the points that you should get accustomed to is that you have to be the most critical examiner of your work. While you send your work out and you get peer review, and you are most likely to get some kind of critical comment, you should be the one who is most ready to critically look at your work and to examine whether you really have done something to the level of detail that your discussion is trying to convey, and so on. And that requires a lot of honesty with yourself, with your immediate group, because when you convey these things in a very blunt and clear manner to your immediate co-workers, you also get feedback which is very, very useful, so that you have actually covered much of the ground that you need to cover when you send a publication out, so that when a peer who is not working with you looks at your paper, he or she also understands that you have really covered a lot of detail. You have looked at all possibilities, and therefore your result is much more believable. So I think honesty is very fundamental in research, because ultimately you are trying to discover something. If you're not being honest about it, there's no meaning in saying you discovered something in it. So that's something.
In that context, I just want to say that there is nothing like a final result and that's it. Research in that field is over, right? People typically use mature and so on, and infancy, the research is infancy and so on. So what is more important is when you critically evaluate your results, to ask first of all if the assumptions that you have made are not too restrictive, as I remarked earlier, and secondly whether the result qualitatively makes sense, and thirdly whether people are able to reproduce what you have done. In fact, there is a theory of reproducible research in which researchers are encouraged, if you are doing computational work, these days they are encouraged to publish codes so that they can be reproduced. Or, if there is an experimental data out of which you have drawn some inferences, post that data if it's not confidential and so on. So you should ask yourself if this result is a one-time affair or you can actually repeatedly do it. And in many times when you, on many occasions when you're performing experiments, there is a repeatability issue associated with it. You should have done enough repeatability analysis. So the critical part is that where you get your result, look at the credibility of the result and ask if it makes sense, if it is reproducible, and then of course talk to your advisor to find out if it is significant. Right.
So I think in this discussion we started off with certain philosophical aspects about what is research. Then we have through the past half hour or so looked at a lot of mundane day-to-day aspects of research, which is what you will actually experience on the ground when you are a researcher in a group. And right now we will again step back and look at a few more philosophical aspects which will help us put a larger perspective on the whole discussion and the process. And with that we'll close. So maybe Abhijit can share.
Yeah, I mean, we started out by posing the question, right, that what is PhD and MPhil, and it's, we want to get these degrees, we want to make a good living. So that's really the underlying feature in some sense, but all throughout our discussion, you also heard that you being the center of all of this. So a researcher sometimes wants to step back and try to look at, what does a researcher do and how is it sort of all this hard work and all this thought and all this laboratory being mined. So how do we sort of place ourselves? How does a researcher place ourselves? And so in all normal things, we are just humans. So just like humans are curious, all humans want to actually improve things around us. And we, of course, all have very appreciation for beautiful things. So similarly, for motivation for research, we many times want to justify our work that we are doing in terms of we are trying to do something which because nobody knows about it, so therefore I want to know about it, therefore I am a researcher. Some other times we may step back and say that no, some of the things that I'm trying to do is actually to improve, maybe make less effort for some manual work, maybe to take something in 2 seconds what used to take longer time. Of course, these days with the world around us also, we are equally, not just humans that we are concerned about, it's the earth as a whole. So therefore, betterment of society and world around us is also an important aspect of why we do research. And of course, one very important aspect in all of this is also we've talked about joy, we have talked about all these emotions, we've talked about being passionate. So therefore, there is a beauty and aesthetics in science. There is something, when we look at a nice equation, we feel very nice about it. When we see a very elegant experiment, we say, oh wow, how could it be shown so elegantly? So therefore, there is, for being a researcher, all of these could be also involved.
So there is an art
Yeah.
in research as well.
Yeah.
We have talked about the science part of it,
Yeah,
but I
yeah.
think research is both science as well as an art. And of course, the degree of art varies from research problem to the other. But I think it's a very important to ask ourselves and be honest with the purpose of carrying out research. I think that's
there are various ways of looking at it. I think one other way of asking this question is we spoke quite a bit about how to do research, and there's also a why aspect. And why we said in terms of passion, etc. But where does the passion come from? So ultimately, the why is answered individually by different people, and I'm sure you will have your own answer when you
it may be for
comes to it. But you have to answer that question.
Yeah.
Well,
It can be as
otherwise
mundane as
you don't survive for a long time in research if you don't know or don't appreciate the why inside of you very clearly. Yeah, that's actually a life philosophy. I think you should know why you're doing something.
So here I want to relate to what Daniel Pink had summarized from research on motivation. Why do people work and why people are driven to work? This is something that he has done very nicely in his book titled Drive, and there he brings 3 aspects. One is mastery, purpose and autonomy. So very interestingly, all these 3 very nicely relate to research. Mastery, for example, is where you see a sense of getting better and better as you go along. Researchers are like that. As you keep on doing research over a period of time, you are very good at the equipment, the techniques, the methodologies, etc. So you can see that you are gaining mastery. purpose, we have already discussed, Abhijit has said that, so we see a larger purpose for the work that we are doing. And then autonomy. Researchers want to solve their problems and the problems for the betterment of people around them in their own way, by choosing the techniques that they wish to use, by choosing the specific methodologies that they wish to adopt, etc. So there's a lot of autonomy by which people work. So naturally, if you put all these things together, researchers are intrinsically motivated.
So I think we have now reached the conclusion of this discussion. We sort of started with a quote from Albert Einstein, and I think it's kind of appropriate to close with a quote from him, since many of us recognize him to be a very significant contributor to the scientific community over the years. And it simply says this: imagination is more important than knowledge. And that's a very philosophical statement, so you need to think about it and interpret it in a manner that makes sense to you, and then possibly utilize it in the manner that you feel is appropriate. So I think with that we will close. I hope you had an overview of what research is, and I don't know if you want to add some closing comment.
And I think what's important is, if you look at, if someone is looking for a workflow for research, the disappointing answer is there is no sequential workflow. However, there are, at each stage, there is a systematic way of doing it. Whatever you're doing, you have to do it in a systematic way and learn to, and also make it a habit to analyze what you get out of, right? And it's a lot of trial and error. There is a lot of iterative process, but at every stage there's a feedback. You take it and then you find out where the problem is and fix it there and come back and so on. So there is a lot of back and forth. However, at each stage, you have to do things systematically and analyze the results that come out of it. But if you look at the grand scale of things, people go back and forth in research, and every researcher goes through that. Not necessarily that the researcher shares those things with us.
So I would summarize saying that if you want to do research, be at it.